Okay, now there's the question. Let's say that V1 and V2 are column vectors, x1, x2, y1, y2, and these vectors are in R2, okay? So we have V1, V2 vectors in the vector space R2. The vector space R2 is just R cross R, okay? You can think of that as x, y, so it's in the xy plane. If these two vectors are in R1, R2, does this imply that V1 plus V2 is in space R2? Well, let's look at what V1 plus V2 would be. If V1 is x1, y, x2, I mean, if V1 and V2 are in R2, then each is going to be a column vector with two numbers, right? So we'll just call those numbers x1 and x2 for V1, and for V2, y1 and y2. So V1 plus V2 is what? Now it's this plus this. Well, what do you do with that? Well, you can add the two column vectors and you get this. That's really straightforward. Okay, now the question is this in the space R2? Okay, well, first place, we can say the vector in the plane is represented by a column vector with two rows of real numbers, right? Okay. So that if this is a column vector with two rows of real numbers, then it would be in R2. Okay, well, if it turns out that x1, x2, y1, and y2 happen to be real numbers, what can we conclude from that? Well, we could conclude that x1 plus y1 is a real number. Because why? Well, because x1 plus y1 is not an aardvark. Wait a minute, that's not a good argument. Okay. And that came up because somebody made an argument that's logically similar to this, but with more mathematical content. Okay, it's clearly not an aardvark, but that doesn't mean it's a real number, does it? Why would x1 plus y1 be a real number under these sets of assumptions? Well, first of all, why would x1 plus y1 be a real number if x1 and y1 are real numbers? Why is that? Because if you add two real numbers, you get a real number. And you state that as saying because real numbers are closed under addition. So we say, okay, if these are all real numbers, then clearly x1 plus y1, x1 and y1 being real numbers, x1 plus y1 has to be a real number. And x2 plus y2. If x2 and y2 are real numbers, x2 plus y2 has to be a real number. We've got two real numbers here, so this is a member of R2. R2 meaning an ordered pair, real number, okay, or column vector. So why is it that x1, x2, y1, and y2 might be real numbers? I said if they're real numbers, then x1 plus y1 is a real number, and we can also argue that x2 plus y2 is a real number. So that, yeah, if x1, y1, x2, and y2 are real numbers, then this is in the vector space R2. Why would x1, x2, y1, and y2 be real numbers? Well, because v1 and v2 are in R2. That means that v1 consists of an ordered pair of two real numbers, or if we prefer a column vector of two real numbers, and so does v2. Which means that if v1 equals x1, x2, then x1 and x2 both have to be real numbers. If there's something beside, if one of these is an aardvark, then this isn't in R2. If one of these is a complex number, we're not in R2. And similarly, v2. v2 is in R2 because y1 and y2, well, V1 is in R2, that means that these two numbers, Y1 and Y2, have to be real numbers. So we have the conclusion that all these are real numbers. Since they are, so are these. So that this is in R2. Okay, this is an important property. This says if you add two vectors in R2, you get a vector in R2. If you added two things and didn't get one of those things, then you probably wouldn't be talking about what it means to add them. Either you have to expand the definition of what kinds of things they are. Okay, well, you don't need to understand that statement. Okay, we'll leave that. We'll go to another video.